All right, guys. So welcome today for another lesson. Let's go over today's objective. I'll be able to determine the domain and range of a quadratic function and represent the domain and range using inequalities. All right, so we talked about domain and range before with linear. Now we're going to talk about how we do domain and range with quadratic functions. And of course, I got you. So we're going to recap real quick over what domain and range is. Remembering that the domain is all the possible x values of a function, similarly that we learned in linear. And range is all the possible y values of a function, similarly what we learned in linear. So when we think about the domain, we're going to be talking about like how wide the function is going from left to right. And when we're talking about range, think about how tall. How tall is the quadratic? That's how we would describe the range. All right, so let's get into an example problem, see how this goes. Okay, so if a ball is thrown into the air, so this is us on the ground. If we threw a ball up into the air, eventually it'd have to come back down and hit the ground. In this example, it went as high as 64 feet and it went for as long as 4 seconds. So if we were to describe the domain and range, the first thing that we're going to do is we're going to do two different points. And the first point we're going to do is at the for the domain, which is at 0, 4. So we're going to go ahead and notate that. And I'll do it in a different color so it'll be easy to see. So we're going to notate this one first. We know that this is the starting point. This is as high as that it ever got. And this is where it stopped. Now, if I'm looking at this, if I'm just going off the domain is starting at the x-axis. And I will do the domain here in green. So remember the domain is the x-axis. So if I'm only paying attention to what's going on the x-axis, I can see where I started and where I finished. I started at 0 and I stopped at 4. So if I want to write this in inequality form, I'm going to have a 0 at the start and a 4 at the end with an x into center, meaning that all of these values are going to be less than or equal to, less than or equal to. As we can see, we're not going to ever go past 4. But the reason why this is continuous is because it doesn't just stop while the ball is in the air. The ball is continuously moving. Hence why we use the vocabulary word continuous. So just like before, we talked about the range being described as like how tall. So now how tall, we're going to look at the y-axis. The y-axis, if we start from here, as tall as it ever got, it went from here down. Okay, so I'm just going to circle that here. That's as tall as it ever went. So we started at 0, which was on the ground, and it went as high as 64 feet. So if I was to write the range, it would be the exact same thing. We're going to start at 0. The highest it got, or the maximum height, was at 64 feet. And because now we're talking about the range, we're going to have a y in the center. And this is going to be less than equal to. And this will be less than or equal to. Because it's always continuous. Okay? It will never go higher than 64, and it'll never go lower than 0. If it went lower than 0, then we would talk about underground. And we're not throwing the ball into a hole. Okay? Let's look at another example. This example right here is asking which graph best represents a function with the range. So let's go ahead and box our keyword here. We're going to box the range, and we're talking about the y values. So we're going to talk about the y values of all real numbers greater than. So remember the greater than symbol looks like this, or equal to -2. So that means, and there's that -2 right there. So we're trying to find a y value that, so it kind of goes with the eat Y, shade high. And so we're talking about eat Y, shade high. These two are shading low. So we know it's not A. we know it's not B. Now, here's the trick. There is a -2 here and also a -2 here. Well, here's the thing. This -2 is on the x-axis and this -2 is on the y-axis. If we're talking about the range and the range is the y, we're talking about the -2 with the y-axis. So that's why our final answer would be answer choice D. Okay, so all this is saying here, if we look at the y values, all of our y values here are going to be greater than or equal to -2. So it can be -2 or it can be -1, 0, 1, 2, and whatever else, as long as it's equal to or greater than -2. So -3 would not be a great value like these here. That's why we could not shade low, because these values, these y values, are less than -2 instead of greater. All right, so you got a lot of practice to do from here. Okay, I hope you guys enjoyed this video. I'll see you guys for the next one.